So these are derivatives of exponential functions, and you're going to like them because they are the simplest of all of our derivatives. So the derivative with respect to x of e to the x is e to the x. So we take our derivative, it's just exactly the same function. So what this means is that any x value, any point that you plug in, the slope of the tangent is the y value. It's pretty cool. So if you have a constant in front, then you just include it, because remember, the constant being multiplied, that coefficient does not make a difference, does not change. So y prime would then become negative 3 e to the x. And I'll show you why all this is at the end. All right, now if you change the exponent to a polynomial or some other expression, then you have to use chain rule. So if you remember our normal chain rule, it's basically this now. You would end up with e to the u and then d dx of u, its normal chain rule. So that exponent is just going to stay whatever it is. So this becomes e to the 2x times the derivative of 2x, which is 2. So we end up with y prime, and you always want to put that in front, e to the 2x. So if you have a constant in front, a coefficient, we would just rewrite it. That's all you're doing. And then you're multiplying it by the derivative of the exponent. So this would become y prime equals 5e to the 4x squared times 8x, and then you multiply those two together, the front and the back. So 40x e to the 4x squared. And that's it. And then this applies now if you have two terms. So remember, that minus is just a little comma. So we'll do the first one first. This is negative 3 e to the negative 7x. So you can see I just brought it down, times the derivative of the exponent. And so we end up with, that would become negative 7 minus 2 e to the 5x times 5. Putting that together, we end up with 21 e to the negative 7x minus 10 e to the 5x. And there you have it. Okay. So now let's try it with a non-natural exponential. So something like 2 or 4 or 5. So what you end up doing is you rewrite it, and then you multiply it by the natural log of the base. So this would become y prime equals, you rewrite just like your exponential with e, and you put ln of 2, the base. And here's a reason why. So if you see 4x, you can think of it as e to the ln of 4x. And then we can use that rule to bring x out. So we end up with this. And so now using chain rule on it, you would end up with e to the x ln of 4 times derivative of the inside, which would just be ln of 4. So the derivative with respect to x of x ln of 4 is just that coefficient that's in front, the ln of 4. All right, and we already know that e to the x to the ln of 4, well, that is just 4x. So it becomes 4x, 4 to the x ln of 4. So whatever your base is, it's just going to get converted up here, and you end up with this. So if you have a number in front, same basic idea. So all you're really doing is this. You're bringing it down, and then you're writing ln of 4, whatever that one is. So this would be y prime equals negative 3, 5 to the x, ln of 5. So it's that quick. All right, so let's try one. So I want you to hit pause now and give this one a shot to see if you can figure out what the derivative would be for this one. So hit pause now. Okay, so if you got that, you're good. You got your exponential basics down. We'll do more in the next video. All right, so I told you I'd explain why it is just plain old e to the x. So remember, our derivatives are the limit of the difference quotient as h approaches 0. So I've already taken my e to the x, and I've plugged in x plus h. So x plus h goes there, e to the x there. Okay, so now if I split it, factor out to the e to the x, I end up with this. That e to the x can come out because it does not contain an h. So this is the limit that I'm looking for right here. E to the h minus 1 over h. And so I've plugged it into the Desmos to show you what it is. So coming in from the left and the right, you can see they are both approaching 1. So even though it's undefined at that point, we don't care. It's the limit. So this limit is approaching 1. So what are you left with? 1 times e to the x, c to the x. It's a nice limit to remember. So the limit as h approaches 0 of e to the h minus 1 over h is 1. So what that means is your derivative of e to the x is e to the x. So that's slope of the tangent. So you have that exponential function going through here, going through 1, like that. That means, remember, at 0, we get 1. So whatever the y-coordinate is, it tells you what the slope of the tangent is. So you plug in 2, well, e to the 2 is the slope of the tangent. Plug in 3, e to the 3 is slope of the is the slope of the tangent. So it's a pretty cool little situation. There you go.